Hey guys, this video is going to be a little bit different than all the other videos you've seen before because we're moving away from the topic of just pure computation, of just pure multiplying, adding, subtracting, and now we're going to be getting into comparing numbers. So this will be the last video before you take your Unit 1 test, okay, and then we'll come back to talking about comparing numbers and number families in the next unit. You may be asking yourself, why am I calling this comparing real numbers? Why am I not just saying comparing numbers? We'll talk about this a little bit more in the next unit, okay, what I mean by that term real numbers. So the first thing I want to talk about in this video is how to work with square roots, which hopefully you've seen before, and specifically how to estimate square roots. So just as a refresher, so the definition of square root is whenever you multiply by a number by itself, that original number is called the square root of your product, of your new number. So just for example, if you have 7 times 7, 7 times 7 equals 49, we would call 7 the square root of 49 because 7 times itself, or 7 squared, gives you 49. So down here in example 1, we have the square root of 64. You've got to think what number times itself gives you 64. That would be 8. Because 8 times 8 is 64. You can also take the square root of fractions. Okay, the square root of 81 over 121 means the exact same thing as the square root of 81 divided by the square root of 121. Okay, so if you just think about that numerator and denominator as being their own separate square roots, the square root of 81 would be 9, because 9 times 9 is 81, and the square root of 121 would be 11, and so the answer to this would be 9/11ths. And then for number 3, we have the square root of 1.21. Well, if you think about the square root of 121, and just take that decimal point out for a second, the square root of 121 is 11, because 11 times 11 is 121. Well, now just think about where would I need to put the decimal in 11 in order to multiply it by itself and give you 1.21. So if you remember multiplying with decimals a couple of videos ago, we said that the number of decimal points in your product is the sum of the number of decimal places in what you were multiplying by, your factors. So if there's 2 decimal places here, that means that this 11 should really be a 1.1. Okay, because if you take 1.1 times itself, you have 1 decimal place and another decimal place that gives you 2 decimal places in your answer. So square root of 1.21 would just be 1.1. Okay, now let's talk about the unkind square roots, or the ones that don't always come out to be nice whole numbers. Okay, so these were nice square roots up here because we know that 8 times 8 is 64. We know that 9 times 9 is 81. But what if we get something like the square root of 28, where we don't have an actual number times itself to get that number? Anytime you get something like that, it's necessary to be able to estimate what the square root is. So we're going to use our estimation skills here. Okay, so let's look down at these 3 examples down here, starting with number 4. We're given the square root of 34, and again, we're doing these without using a calculator. So what I want you to do is I want you to think about what are the 2, we're going to call them perfect squares. So what are the 2 numbers that we know square roots of? One that's larger than 34 and one that's smaller than 34. Okay, again, those are called perfect squares. So for 34, you know that we have 36, which is called a perfect square because we know what the square root of 36 is. And we also have 25, okay, which is a perfect square because we know what the square root of 25 is. So what we're going to do is we're going to say, okay, by logic, 34 is bigger than 25, okay, but less than 36. So that means that 34 has to be somewhere, the square root of 34 has to be somewhere in between the square root of 25 and the square root of 36. Well, you know the square root of 25 is 5, and you know the square root of 36 is 6, so that means that the square root of 34 has to be somewhere in between 5 and 6, so it's going to be 5 point something. Okay, the question is, what's that something? 5 point what? The way you do that is you figure out what is 34 closer to. Is it closer to 36, or is it closer to 25? Okay, and if you're good with subtraction, you hopefully can see that 34 is a lot closer to 36 than it is to 25. If you think about a number line, 34 is 2 away from 36, it's 9 away from 25. So that means that if we thought about this number between 5 and 6, right in the middle of 5 and 6 is 5.5. Okay, the square root of 34 is a lot closer to the square root of 36, so that means that it's going to be closer to this side, okay, this side of 5.5, so the square root of 34 is going to be something like maybe 5.7, 5.8, okay, something along those lines. That would be a good estimate for the square root of 34. So we're just going to go ahead and I'm going to say that this would be about 5.8. You could say 5.7 if you wanted to. You just need to give me a number that's larger than 5.5 but less than 6, okay, is how we're doing this. Okay, let's try another one. If that didn't make sense to you, you can try this one. We'll do it the same way. So we've got the square root of 52, and again, we're trying to think, first of all, what two perfect squares is 52 in between? Okay, well, we know the square root of 49, okay, and so 52 is larger than 49, and we also know the square root of 64, and 52 is smaller than 64. Okay, so it makes sense that the square root of, so 52 would be in between the square root of 49 and the square root of 64. The square root of 49 is 7, and the square root of 64 is 8, so that means that the square root of 52 needs to be somewhere in between 7 and 8. And again, right in the middle would be 7.5, but we want to try to get a little bit closer than that. We want to think, okay, is square root of 52 in this region here, is it closer to 7, or is it closer to 8? Okay. Well, now you compare 52 to 49, which they are 3 apart, and 52 to 64, they are 12 apart. So 52 is a lot closer to 49 than it is to 64. That means that the square root of 52 is going to be on this part of the number line. It's going to be somewhere less than 7.5, so we may just say 7.3 for that. So a good estimate for this would be 7.3. Okay, now I want you to try number 6 on your own. Try the square root of 142. Click pause, estimate that to the nearest tenth, and then to check your answer, click play. Okay, hopefully for this one you got an answer close to what I did. I got about 11.8, or maybe you said 11.7 or 11.9. So the square root of 142 has to be in between the square root of 121, which we know is 11, and the square root of 144, which we know is 12. So it's going to be somewhere between 11 and 12. And because 142 is a lot closer to 144 than it is to 121, I said it's going to be larger than 11.5, so probably about 11.8 would be a good estimate for that. Okay, so that's how you estimate square roots, again without a calculator. Now we're going to go on to how to compare multiple numbers, and to do that we're going to use what are called inequality symbols. And we'll actually be doing a full unit on inequalities here towards about midway through the year. Okay, we'll be learning how to solve inequalities. For right now, though, I just want you to know what these different symbols mean. Okay, and you've hopefully seen these before. Okay, so this symbol right here, okay, it's just like a sort of an arrow, or sometimes your teacher might refer to it as a crocodile's mouth. This is this symbol for less than. Okay, so you read that symbol as less than. This symbol here, you read that as greater than. This symbol here, it's a less than symbol with a bar underneath it. That means less than or equal to. And then this symbol here is going to be a greater than or equal to. Okay, this symbol here, hopefully everyone's familiar with. That is just an equal sign. And the reason I put that in there is so I could bring up this symbol right here. If you see an equal sign through with a slash through it, that means not equal to. Okay, so if you had something like 7 and 5, we could say 7 is not equal to 5 because 7 and 5 are different. The two I want to really focus on today, though, are these first two, less than and greater than. We'll be talking about the rest of them more in depth again when we do a unit on inequalities. But for now, today, we'll probably just be using these two right here, and then also our equal sign occasionally. So let's go now to examples 7 through 11. And what we're going to do is we're just going to compare these two numbers using one of those inequality symbols. Again, greater than, less than, or sometimes we'll use the equals to. So we're comparing, first of all, number 7, two fractions, 6 sevenths with 7 ninths. The way you compare fractions is you always want to make sure, just like when you're adding and subtracting, that they have common denominators first. So I'm going to get the common denominator of 7 and 9, which would be 63, and I'm going to multiply this first denominator by 9, and that means I need to multiply the 6 by 9 as well, so that becomes 54 over 63, and then the second fraction I'm going to multiply the 9 by 7, and then also this 7 up here by 7, so that gives me 49 over 63. Now that I have common denominators, I can just look at the numerators and figure out which one is larger. 54 is larger than 49, so that means that this fraction on the left is bigger than the one on the right. So I'm going to include a greater than sign. And then finally, for my final answer, I'm going to reduce back down to my original problem. So 54/63 was actually 6/7. So I know that 6/7 is actually greater than this was 7/9. Okay, but get common denominators first to compare them, and then write your final answer with the original numbers you were given. Okay, for number 8, we have decimals. Decimals are probably, besides whole numbers, the easiest numbers to compare. All you do is you start as far left as you can, and then you just compare numbers one decimal place at a time. So we have 5 point something and 5 point something, so they're both have a whole number of 5. That does us no good, so now we'll move on to the tenths place. We have 5.8 here and 5.8 here. 8 and 8 are equal, so now we're going to go on to the hundredths place, and we'll just keep on doing that. We have 4 and 4 until we get to two numbers that are different. So going to the thousandths place, we have 2 and 7. Okay, 2 and 7. 7 is larger than 2, so that means that this number over here is just slightly larger than this number here on the left. So we're going to put in a less than sign to say that 5.8423 is less than 5.8473. And again, we got that by comparing decimal places until we got to two that were different. Okay, number 9, we're going to compare two fractions again. It'll be the same thing as what we did in number 7. We want to get common denominators first. So 4 and 16, the common denominator would be 16. So I need to multiply this first fraction by 4 on top and bottom. That's going to give me negative 12 over 16. My second fraction I can leave alone since it's already got a 16. It would be negative 15 over 16. The one thing you have to be careful of for this is these are negative fractions, and so negatives again work the opposite way of positives when you're comparing. So in this case we have a negative 12 and a negative 15. Negative 12 is actually larger than negative 15, again because we're in negative land. So that means that negative 12 over 16 is actually greater than negative 15 over 16. So my answer is going to be, this was originally negative 3/4. Negative 3/4 is greater than negative 15/16. Okay, for number 10, we're comparing a mixed number to a square root, and we're going to again practice our estimating skills for the square root of 17. So square root of 17 is going to be between, and now I can use my inequality symbols, the square root of 9 and the square root of 16, which means that the square root of 17 has to be somewhere in between 3 and 4. And I can actually just stop right there. I don't need to figure out if it's 3.8 or 3.2. The fact that it's between 3 and 4 means it's going to be smaller than 14 and 1/3. So I know that the square root of 17 has to be less than 14 and 1/3, just by using that logic there. Finally, on number 11, we have the square root of 129, comparing it to this decimal, 11.87392. So I'm going to do the same thing I did in number 10. I'm going to estimate the square root of 129 first. I know it's between the square root of 121 and the square root of 144, so it's got to be between 11 and 12. But I'm going to have to go a little bit further than that because I'm comparing this number between 11 and 12 to 11.87392. So now I need to figure out, okay, what's a good approximation for square root of 129? Is it closer to 121 or closer to 144? Well, if you do the differences here, again, this would be 11.5 right in the middle. If you do the differences here, 129 and 121 have a difference of 8. 129 and 144 have a difference of 15, and so that means that the square root of 129 is going to be closer to this part of the number line, so it's going to be less than 11.5, and that means that since it's less than 11.5, 11.87392 is going to be larger. So we're going to say that square root of 129 is less than 11.87392. Okay, the last thing I want to do is I want to talk about how to compare multiple numbers, and we can use a number line to do that. So if we're comparing more than two numbers, sometimes it's easiest to do that using a number line. So in example 12 down here, I have these numbers. I have 0.4, negative 2/3, negative 1.5, 7 halves, and then the square root of 5. So we're going to put each of these on the number line above. Okay. Okay, and so to do that, I'm going to try to get all these in the same format, and I like using decimals myself. So 0.4 is already a decimal, so I'm going to leave that as it is. Negative 2/3, you should know what the decimal equivalency of that is, okay, from studying those in 6th grade. Negative 2/3 is going to be the same thing as negative 0.6 repeating, okay? So make sure you know that conversion there if you don't already. Then we have negative 1.5, again already a decimal. 7 halves is going to be the same thing as 3.5, which is the same as 3.5. And then last thing, the square root of 5, we'll just do that estimating trick again. We know it's between square root of 4 and square root of 9. So it's got to be between 2 and 3. And it's pretty close to, square root of 5 is pretty close to square root of 4, so I would say maybe 2.2, okay, 2.1 even, would be the square root of 5. So if I go fill out my number line now, all I'm going to do is I'm going to put each of these numbers on the number line and label those, and then I can compare them from left to right since I want to know what are they least to greatest. So 0.4 is going to be almost halfway between 0 and 1. So 0.4 would be about right here. Okay, so we're done with that. Negative 0.6 repeating is going to be about halfway between 0 and negative 1, just a little bit closer to negative 1. And remember, that was actually negative 2/3. Okay, it was negative 0.6 repeating, so I'm going to label that as negative 2/3 to keep this in the original format it was in, a fraction. Negative 1.5, okay, that was a decimal originally. That's exactly halfway between negative 1 and negative 2, so right there. 3.5, remember we said that was 7 halves, was the same thing as 3.5, so I'm going to write this as 7 halves. It's exactly between 3 and 4, would be right up here. And then lastly, 2.2, also this square root of 5, that's going to be just a little bit to the right of 2, just a little bit bigger than 2, so I'm going to label that as square root of 5. And now I have those 5 numbers in their original format. So now if you just go from left to right, it's easy to see that the smallest number was negative 1.5. And then we have negative 2/3, 0.4, the square root of 5, and 7 halves. So that's how you can compare multiple numbers if you just draw a number line. That's usually the easiest. Okay, that was a little bit longer video, but hopefully it made sense. If you need to, go back again and review anything that didn't make sense the first time. Write down a question or two that you want to ask the next time I see you. Until then, have a nice evening. You are all wonderful people.